操！把我的零食裁了啊！
So it's a title of all titles, the integrations of inverse trig functions. So truthfully, tonight when the snow is falling and your parents are like, hey, get out there and shovel, you'll say, but no, I need to work on my integrations of inverse trig functions. So it's a good time to be doing this. So I'm going to make sure you guys have tons of homework so you don't have to shovel snow tonight. It's okay. Here's number one. I think if you guys are keeping track, some of you guys like to know how many there will be. There is 6 questions. 6 questions. Question number 1. If I suggest to you, I want you to consider the integral. Oh, these are so much fun. It's going to be, I'm just kind of giving you the formula, then we're going to apply it. So du suggests somebody's taking a derivative of some function named as u. And then downstairs, it's the square root of a squared, which is a constant. A is a constant. Minus u squared. And we can finally answer this question. So you can take an ugly rational function with a square root and shenanigans, and you can finally integrate it. The integral of this particular function is arc sine. So the integral is arc sine. And then inside, you've got u over a. That's interesting. Plus c. So now you can integrate a rational function. So rational means it has a denominator. And you can do so using this technique, if it fits. Sometimes the fit can be a bit of a challenge. All right, so here's the example. So we're still in number 1. Upstairs is dx, so we're going to have to change the conversation, I guess. And then downstairs, it's 16 minus x squared. All right. We need to make this work. We need to make this fit. First things first, please notice the order. The order matters. So notice that it's the number, then it's x squared. If it's the other way around, that can cause us some grief, or maybe we're supposed to be working with someone else. When we take a look at this here, is it clear what a squared is? It is 16. Therefore, what is a? 4. All right. Based on what we see, what is u squared? U squared is x squared. So then what is u? X. And then what is du? 1 dx or just dx. Now, can we change the conversation in terms of a and u? So we're going to do it this way. Is it safe to say then it's going to be equal to arc sine? The fit for this particular integral is arc sine. Now, we could write it as u over a, but don't we already have the description for u? What is the description for u? Is it not just x? And what's the description for a? 4 plus c. Yes. No. Because at the end of the day, no matter what the value is for a, what do we do to a? We square it. And when you start thinking about these inverse functions, did we not sort of restrict to make our lives easier? Now, I feel like we should check this, right? Because sometimes I give you stuff and I want you to not necessarily trust everything you're given these days. If I asked you, could you take the derivative of this function? Does it return to what we expect it does? So this is a bit of a practice, of course, of the homework that you did yesterday. All right. How do we take the derivative of arc sine? Well, isn't the derivative of arc sine, I know there's lots of missing pieces, but isn't it going to be 1 over the square root of, and then isn't it 1 minus, if you go back, arc sine is 1 minus, and if we recall, is it not 1 minus u squared? So in this case here, and maybe we'll write it here so you guys can see it because I know it's been a little while. If I ask you to consider the derivative of arc sine of u, so I'm giving you what we had from, I guess, Tuesday, is this not 1 over the square root of 1 minus u squared, but then you multiply it by the derivative of u itself? Okay, that's the formula, or sorry, not the formula, but that's the process we follow. So in this instance, isn't u x over 4? But then what do we do to the x over 4? You square it. And then you're supposed to multiply it by the derivative of u. Well, in this case here, what is the derivative of u? 1/4. And I got to admit, right now, does this seem to look like what we started with in terms of the integral at the beginning? Are these two the same? Sure does not look like 16 minus x squared right now. All right, well, to give some credit where credit is due, Gary kind of helped us with this. If I rewrite this, can I not rewrite it as 1 over, and I see the quarter that's here, so can I put the 4 in front? And I'm actually going to make it a really big 4, so don't get confused. So I'm going to make a nice big 4 in front, and it's being multiplied by, and initially, is this not 1 minus x squared over 16? And next, what you should do at this stage here is build a common denominator, right? Underneath the square roots, right now you have something over 16. So can we not rewrite this as 1 over 4 times the square root of 16 minus x squared all over 16? And maybe just because I can do it easily, is it safe to say that this is 4 over 1? Does that make it a little clearer? Then can we factor out, and actually, I loved how Gary arranged this yesterday. Could we rewrite this as 1 over 4 over 1 square root of, and then factor this out as 1 over 16 multiplying 16 minus x squared? And then can we factor out the 1 over 16? And when we factor out the 1 over 16, is it safe to say that the 4's change into 1? And at the end of the day, is this exactly what we started with? Okay. So we understand that inverse, and I'll say that better, integrals and derivatives are inverses of each other. Okay. Do you need to take the derivative to confirm if you're right? No, but it's nice to have that option. All right, next question. Number two. Wow. I'm going to introduce to you somebody else. I don't know why I'm going 3 levels here. We're not going 3 levels. We're only going to go 2. We'll just make it bigger. All right. Upstairs, you've got du, which suggests there's another u. And in fact, you guys might recognize it's just going to be a squared plus u squared. When it's a squared plus u squared, it's definitely not arcsine. To be arcsine, you need a square root. There's no square roots. So who do you think this relates to? You know what's funny? I don't do arc cosine ever. Because I'm going to remind you, is the only difference between arc sine and arc cosine is a minus sign. So when I integrate, I only integrate it into arc sine. If there's a minus sign that's causing me grief, I factor it out. Okay, and we'll deal with that more. So the nice thing is when we do integrals, you only need to know 3. Okay, it makes your life easier, Gary. It is arctan. Tan is the one where there's no square root. Think about what the derivative of arctan is. The derivative of arctan, check your notes. There is no square root when you do the derivative of arctan. So just so we're clear, it's going to look like this. It's going to be 1 over a, because there's a constant that comes out that we need to deal with, multiplied by arctan. And then with the understanding that's within arctan is u over whatever that constant is. And of course, plus c at the end. You'll like arctan. It's the easiest one to manage. There is no square root to worry about. Okay. So if I said to you, hey, could you find the integral of dx divided by 4 plus x squared? Okay. Now, do you notice, like, normally when we get these rational functions, we do like division. You guys all have the same cold? Like, are you sharing it? I'm sorry, you guys have a cold. Spring colds suck. Actually, to be fair, don't all colds suck? Okay. Can you see there's no numerator? Like, we're never doing long division with this question, right? You can't take the top and divide it by the bottom because the top is simply 1. However, can you notice there's no square root? Can you notice it's a constant plus something squared? When you look at this question, then, if I asked you the first part, what do you think a squared represents in this question? 4. Okay, fine. So what's a then? Now can you see we've correctly identified the value for a? All right, in this question, I know it feels kind of silly, but what is u squared in this question? It's x squared. So then what is u? X. And for now, since there isn't much fun to be had, is it true that du is the same as dx? All right, let's rewrite this integral in terms of u and a. I don't think we even have to do that much, to be honest with you. Why don't we just do the integral? So it's going to be 1 over, what is the a value? 2. Arctan, what is representing u? X. And then what is a again? 2. Plus c. So you need to be able to do 2 things. A, recognize, is it arcsine? Is it arctan? Is the pattern there? But more importantly, managing what a squared and u squared are. That's going to become more complicated. All right, that's number 2. Here comes number 3. Ooh. Number 3. Well, you're considering another integral, and upstairs you just happen to have du. And then there's all kind of weird things going on downstairs. You've got u on the outside multiplied by the square root of, and then underneath it happens to be u squared minus a squared. Yikes. Bearing in mind that u itself most likely is greater than 0. All right, Ethan. Yep. What do you think is the best way for us to integrate this function? Close. You got the correct function. The trouble is that when you take the derivative, you would never do that because that would be like the absolute value of a function. You're factoring out the constant. You're on the right path, though. It's 1 over something. It's going to look like, you're ready? It's going to be 1 over a. And then it's going to be arc secant of u over a plus c. The good news about this one is because it's so awkward, it's easy to identify. You're going to have more concerns when you're trying to manipulate something so it behaves, or we can integrate it using arcsine, or manipulate it so you can integrate it using arctangent. So when these ones show up, it's like, well, it ain't arctan. I know right away it's not arctan because there's a square root. And when there's a square root invited, arctan will never show up. And then there's more going on downstairs than you expect. And then the big clue is the fact that it's u squared minus a squared. Notice the order is different. When you do arcsine, it's always the constant squared minus the function squared. When you do arcsecant, it's always the function squared minus the constant squared. That order will dictate which one that you will use. Okay, here's a very tidy example that goes with arcsecant. By the way, you will never do arccosecant because the only difference between them is a minus sign. So you don't have to consider it. You'll just factor out the minus sign and then make it work from there. You'll see it in some examples in the future. All right, here is your example. So I want you to consider the integral. We got dx upstairs as expected. And we're going to keep this pretty friendly. We're going to turn this into x square root, and then underneath the square root, we're going to give you 4x squared minus 9. Yeah. Well, I think I know. What do you think the a value is going to be? I think you can, if you look at it, you can tell me what a is going to be. Can you tell me what a squared is? Yeah. No, let's start with a squared. What's a squared? In this example that we're looking at right now, what do you think a squared is? No. No, a is always a constant.
Oh, no.
Right. So let's get that piece correct, right? So if I say to you that a squared is equal to 9, what do you think a is? 3. So we can already start it. We know it's going to be 1/3 arcsecant something over 3 plus c. We are like, my way of dealing with life. I'm solving what I know how to solve first, and then I'm worrying about the other pieces later. All right. here's where our problem starts. What is u? Because right now, u, the way it's given, is a little bit inconsistent. Based on what we see, let's focus our energy on u. And when we focus our energy on u, let's focus our energy based on what we see inside the square root. And maybe what we should be doing is focusing our energy on what is u squared. So Jim, just because you're always great to work with, what do you think u squared is in this example? Yep, it's exactly 4x squared. Okay, and then what would u be then? Okay, 2x. So now can you see our problem? Because based on the format, isn't this u here and this u here, are they not supposed to be the same? But right now, they are not the same. Is there a way that we could manipulate this so that they become the same? And notice we're not manipulating underneath the square root because that's a pain. Is there something that we could do to this fraction such that we get the 2 that we want in front of the x? Multiply by a convenient version of 1. And in this case here, could we multiply? So before we integrate, could we not multiply this by 2/2? We agree that 2/2 is the same value as 1. Then when we rewrite this, can we restructure our integral in the following fashion? It's still going to be the integral, but now can you see that downstairs is a perfect match? Where 2x makes sense because that's what u must be. Inside, it's going to be, and I'm going to just rewrite it as, is it okay if I write it like this? As 2x all squared, because isn't that what 4x squared is? Just to remind us that's what u represents. And then minus, and if it's okay if we're going to do that, could I write 9 as 3 squared? Okay. However, we can't forget about how we modified the conversation. So what do we do with that 2 then? The one that's in the numerator. Just factor it out. Can we not put that 2 here? And then you've got dx alone inside. Once you've done this, you've got all the pieces organized so that we can integrate it. All right, here we go. It's going to be equal to 2 times all of the nonsense that we're going to create. All right. It's going to be arc secant because you got the function outside the square root and the function inside the square root. Here's the good news. Oh, wait. Uh-oh. Uh-oh. Before I make the mistake. When we look here, how do we describe du? Is it not 2 dx? So I'm glad that I got too excited. I failed to consider how that's going to impact our question. So if we recognize that du is 2 dx, don't we have to then suggest that du over 2 is the equivalent of dx? So then, truthfully, shouldn't this be 2 divided by 2? If we incorporate the rate of change of u into the question. So if that's the case, just for fun, is this not just 2/2 on the outside here? Again, this convenient version of 1 shows up. Not a bad thing. As we move forward, though, it's going to be 1 over the a value, which happens to be 3. Arc secant U is simply 2x, and A is just 3 plus C. And then you'd simplify it, and obviously the 2 over 2 turns into 1. I'll write it so there's no misunderstanding. So please remember to incorporate the rate of change into your integral. Are we clear? It's your way for compensating for the chain rule that occurred. Yes, Gary. So it's a really good question. I gotta admit, usually I just ignore it. It depends on circumstance, depends what they're doing in the question. Like you're saying, like, why is there not here? And maybe in the question, maybe there's a suggestion where x is greater than 0. And if x is greater than 0, do we need the absolute value brackets? No. Okay. Yeah, I kind of jumped ahead and I didn't write it out correctly. I know what you mean. Yeah, so if we were going to do this correctly, like I kind of just jumped down the line. Hold on. Let me do the next question. Okay. Because it's going to take time to restructure it. I didn't actually do the U substitution properly. I got the right answer. I just kind of bypassed that step. All right, here we go. Number 4, can you consider the integral? Obviously, it's going to be a fraction. And downstairs, you've got 2 plus 9x squared. Can you find me the integral of this rather friendly rational function? And again, you can't split the bottom, you can't unmerge, you can't do long division. You can only use an inverse trig function to help you integrate this question. So Thomas, that kind of like you asked me about like we didn't do the substitution correctly. In theory, that's what it would look like if you did the substitution correctly, and we've incorporated the 1/3 on the outside. All right. And then you can go ahead and take the integral. And then it's going to be 1/3. And then which of our 3 options will it be? Is it arc? Now be careful though, it's going to be 1/3. So arctan is going to be 1 over A. Like if we're going to do this by the letter, then it's going to be arctan of U over A plus C. However, we want to answer the question in terms of x and in terms of the constant that we know. So if we rewrite it one more time, it's going to be 1/3 of 1 over what is a? Square root of 2. And then it's arctan of the replacement for u is 3x all over the square root of 2. The only other thing I would do here is like, do I want you to rationalize this? No. Just leave it as is, it's fine. Like, I don't see any value if you want to rewrite it as 1 over 3 roots of 2. Do not rationalize what's inside here either. Just leave it. Good? All right. That's number 4, which means we've got how many remaining? 2. All right. Number 5. All right, well, I want you to integrate. It's going to be a rational function. And then it looks like this downstairs. You ready? X squared, like that, minus 4x, okay, plus 7. I don't like how it looks. Can I change how it looks? Guarantee you one thing, it's definitely going to be arc10. No square root. Don't like something got one correct solution. Somebody looked at that denominator and said, damn it, like I change you into something I do like what you think. need something squared to something else. I got some part there.
Not for me, but it's right.
Do the answer. Ah, see your formula sheet. Lousy. No. I'm impressed. You guys have impressed me. Usually most guys continue to stick to it. There's a rumor going around about completing the square, but it's not really completing the square. It's funny because like the way I teach it, but the people that have done it haven't done it the way that I teach it, but I kind of like how they've done it better than the way that I teach it. If we just focused our energy on the bottom, but I'm focusing like my energy on these two terms. And remember how we taught you? So I'm going to show it both ways. So those of you that did it differently, you'll see it's going to be the same. Okay. If I said to you, you got x squared minus 4x, what would you do to complete the square? What would you add into the conversation? So remember, you take the middle term, you divide it by 2, and you square it. So if you take minus 4, you divide it by 2, and you square it. Don't you add 4? So just so we can follow that theme, so I feel confident with that. So we are manipulating the integral before we integrate. Could we not rewrite this as x squared minus 4x? And then can we just add in 4, wrap the brackets around it because it makes me nervous? And then could we subtract 4? Because isn't that what you're supposed to do when you complete the square? You add 4, but then you subtract 4. But then don't forget about the 7 that's hanging around outside. And then now we can factor this into a perfect binomial squared. So if we rewrite it this way, so like Jason, don't change how you did it. And Gary, don't change how you did it. But when we move forward with this, it's simply the integral here. This is x minus 2 all squared. When you completed the square, is this not x minus 2 all squared? And then on the outside, you've got minus 4 plus 7. That just happens to be plus 3. Agreed? Now, does this sort of look like tangents? Now, I know the order is kind of backwards because when we do tangent, you're supposed to have like a squared plus x squared, but who cares? They're both positive. It's irrelevant. All right, I'm going to tell you then in this question here, what is a squared? What's a squared? 3. So then what is a square root of 3? In this question, what is u squared? X minus 2 all squared. So what is u? X minus 2. Now be careful because I'm the one that forgets this, so you got to keep track of me. Have we considered du yet? No, but let's do du. What is du in this case? 1. So it's a perfect replacement, no adjustment required there. Nothing needs to be factored out later. And if we do this here, and then, Thomas, can you see why I don't kind of do this by the letter of the law? It's always 1 over a. So the integral is going to be 1 over a. What is the a value? Square root of 3. By the way, who is this? Arctan. And then inside, it's supposed to be u, which just happens to be x minus 2. And then it's all over a, which happens to be the square root of 3 plus c. Jason and Gary, do you want me to show what you guys did? It is the same, but that's why I wanted you to see it, right? So what they did, and I like what they did, is they looked at it this way and they made it less complicated than me, which is not really surprising because don't I just make everything more complicated? What they did is they said, look, when we look at the bottom here, can't we just rewrite this as x squared minus 4x? But they broke up 7. They said, why don't we just describe 7 as plus 4 and plus 3? Is that not the equivalent of 7? And then they just went from there. Do you like that? There is no difference. It's just, I think students are used to this concept of like completing the square, but I don't care which way you do it. You're just manipulating it into something that we do like, right? Like mushy peas. I don't think Magnus actually likes mushy pea. They're good. Yeah, fish and chips. All right. Oh, wait a second though. Do you eat your baked beans warm or do you eat them cold? Just checking. All right, last question. I did used to have a student, Magnus, a long time ago, and he would come in, I'm not lying, he would bring a can of baked beans with him and a can opener. And he's opened the can and then he would just eat the can of baked beans right there. Yeah, I like heating them up too. Yeah, I like it. All right, last one then. Oh, Nelly. Okay, let's have fun with this one. I want you to consider the integral of dx upstairs. So right away, there's nobody upstairs. When there's nobody upstairs, it's probably one of the trig, inverse trig integrals. Okay. Downstairs, not a lot of fun downstairs. You've got the square roots, so I'm okay with that. So right away, tan is no longer invited. But you've got 6x minus x squared. And I'll make it easier on you. It will be arc sine, but you're going to have to play with it to make that happen. Remember, it's always a squared minus 2 squared. You don't like how it looks? Change it. You deserve.
Wrong. Why is it that for side don't we 1 over 8? I don't know No.
So there's different ways that you could reorganize it. Like if you added 1 to both, might be easier. It's going to be 790 to the 6. Yeah, like I'm
sitting there.
I'm not bad. Mr. Sullivan is better at arithmetic than
He was like, so where I went talking to Christian 9:59, because we could do 85.
he's playing 9. That's interesting. He always played me. Every time you guys make a mistake, it's my fault. Here we go. So somewhere we understand that we want this to look like the integral. I guess we should probably use a u here. Like we want it to look like this, don't we? Now be careful. It's supposed to be the constant squared minus whatever function you have squared. That's what we want it to look like. It does not look like that right now. Agreed? So we're going to take a look at the bottom and we're going to have some fun with the bottom. We're going to go over here. We're going to rewrite it out as 6x minus x squared. By the way, why are we doing this? Because we have no other option. Okay. It's not like we can do long division for this. It's not like we can unmerge to do something. We need to manipulate this so it fits. Here's the first thing you're going to do. You're going to factor out the minus sign. So you're going to create x squared plus 6x. Wrong, Mr. Harley. It's going to be x squared minus 6x. Hey, don't you like the self-correcting version of Mr. Harley better? All right. Then guess what? You're going to complete the square. Now, when you do this, be careful though. You're going to have to add in 9, and then you're going to have to wrap the bracket around. Now, be careful though. If you add in 9, you didn't actually add in 9. Did you not add in the opposite of that? So if that's the case, then what's the opposite of adding in 9? Isn't it not adding 9? Can we see that? These two signs always have to be the opposite. Then when we rewrite this, and I'm going to change the order so it's going to match, is it not going to be 9, positive 9, minus, hello, x minus 3 all squared? Is this equivalent to what we have underneath the square roots? And the answer is yes, yes, it is. Because we added in 9 and we subtracted 9. Can we see we compensated for both changes? Does this now look like something we can integrate? So if we go back to our function, we're looking at the integral then of dx. And now downstairs, we have reconfigured and created 9 minus x minus 3 all squared. Notice what I said. The constant has to go first. The function has to go second. And there must be a minus sign between them. And the truth is, like Thomas, for this one, because I know it's going to be arc sine, I'm not going to bother with the whole, well, I should be careful. You know what? I'll be careful. A squared is equal to 9. What is A? Good. U squared is equal to x minus 3 all squared. What is U equal to? And again, I'm the one, I forget about making sure I work with du appropriately. And in this example here, there's no issue. But there could have been. All right. Now that I've dealt with the du properly, I'm okay with if you just want to tell me that this is going to be equal to. Well, it's arc sine. It doesn't worry about something coming out. So it doesn't have the 1 over a. The other two do. U happens to be x minus 3. A happens to be 3. And at the end of the day, plus C. How do we feel? Good? All right. All right. Here's your homework. So we're stealing pieces from two different sections. So 5.6, pages 378 to 379. And they are questions numbers 41 to 51, ODD. And then 61, 63, 77, 83, 85. And these are all derivatives. Then we're going to jump into 5.7. This is on page 385. And you'll do numbers 1 through 17 ODD. And then 21, 23. Have fun with them. Some of them are pretty straightforward, but some of them you will have to be creative with. Good luck. Hold on.